You can also do a confidence interval. So, several years ago, 33% of parents who had children in grades K-12 were satisfied with the quality of education that the students receive. A recent poll asked 1,195 parents who have children in the K-12 if they were still satisfied with the quality of education. Of the 1,195 surveyed, 472 indicate that they were satisfied. We want to construct a 99% confidence interval to assess whether this represents attitudes have changed. It doesn't say more. It doesn't say less. It says changed. Changed means does not equal. So when you're constructing your null and your alternative hypotheses, this is a proportion, right? Because it's the percentage again. My alternative is going to be does not equal. I just need to know change. So when I'm looking at a confidence interval, kick it back to our formula sheet again. So in our formula sheet, we are going all the way back over here to chapter 9, and we're doing the same formulas. That's why you keep it handy. It's a confidence interval. All right. You're going to go back and use the confidence interval from chapter 9. It's the same thing, right? So let's do it. In order to use my confidence interval, I have to have an upper bound and a lower bound. So I'm going to change colors here. I'm going to make my lower bound. And then we know that this is going to be p hat minus my critical value, and the square root here of p hat 1 minus p hat all over n. And then you plug that in. Now here's the kicker. This is not a p naught situation. So I am not using this value. I am using p hat. Right? Okay. 472 divided by 1,195. And again, check it on your calculator. It's at 0.395. I also need my I also need my critical value. Get that from your chart. Ooh, look at here. Remember, we have that chart down there at the bottom. Use that chart. It is super handy. So my critical value here is 2.575. Now I just plug it all in. This is equal to my p hat of 0.395 minus 2.575 square roots of 0.395, 1 minus 0.395 all over 1,195. Again, pause it, check it. And your lower bound is 0.358 something or other, but I'm just going to go to 2 decimal places. So 36 is what that should say. I don't know where that came from. All right. Your upper bound, you're going to do the same way. Except it's going to be a plus, right? So I have 0.395 plus 2.575 square roots of all of that. All over 1,195. So my upper bound, again, plug it into the calculator, come back, and you see your upper bound is a 0.43. So my question to you now, in order to determine if this is valid, does 0.33 go in my interval? I'm saying my new survey, the data I have now collected, the new data for my alternative up here, is going from 0.36 to 0.43. Does this fit in? No, it does not, right? So since this does not contain what I have, then there is sufficient evidence. My new evidence shows that the information has now changed. Therefore, since the interval does not, maybe I should have put it over there. Oh well. Contain that 0.33, there is sufficient evidence. That parents' attitudes have changed. And honestly, look what happened. They've gotten better, right? It used to be just 0.33. It's changed, and honestly, it's changed for the better. So that's a good thing, right? Moral of the story that you're going to take, here's your takeaway. Are you looking at your test statistic with a p-value, or are you going to have to do a confidence interval? And those are the formulas out of chapter 9, right? If you have questions, make sure you're emailing me on this stuff.